Hello, I'm back, and so are you. We are starting set B for this week. There are a couple topics in set B. This is the video for the first topic, B.1. And this is a super adorable cartoon sent in by one of you, so thank you for sending that in. It makes things just a little bit nicer, so, because right now it's just me and the cats hanging out. But anyway, so for our first topic, we are dealing with arc length. All of this is going to be online, just at tinyurl.com/geodig, Geodig. And then this page, when I send it out to you, will also have links to everything in your OneNote as well. For the notes, when you look at this, the link to the video will be there with a link to the video I'm creating right now. There are also filled out notes in PDF form if you want to look at it that way. But as we did last time, there will be a few spots where I'll ask you to pause the video and try something on your own, and then you can unpause and I will have already filled it in. So let's get started. What we'll look at today in this topic, B.1, is arc length. So before we talk about how to find arc length, I want to talk about how that's different from what we've done with arcs in the past. So we've dealt with arcs, they are just parts of circles, and we have done measures of an arc before. So this blue arc, forgive my surface writing ability or lack thereof, this blue arc and this red arc, if I measure them, you may remember from a while ago, it seems like 15 years ago, that the measure of an arc is the same as the measure of its central angle. So if this is a right angle in here, then that's a 90-degree arc. And over here, even though the circle is smaller, the central angle is 90 degrees, so the measure of that arc is also 90 degrees. Basically, the measure just tells me how much of the circle gets taken up. On the other hand, same picture, but if I want to measure the length of the arc, well, in that case, I'm more interested in how much is actually there. So when we did, at least in Miss Kennedy's class, when we did the crust and corner thing with pizza slices, now I'm actually interested in actually how much crust I get to eat, not just what proportion of the circle is there, but how much crust there is. And so if I'm measuring length, then on the bigger circle, even though it's still a 90-degree arc, there is more crust, and so that would have a greater arc length. Super important, and really the main way to think about this, for arc measure, the units are always going to be degrees. The measure of an arc is related to the measure of an angle, and so the measure is always in degrees. Whereas the length, if I'm talking about pizza crust, if I kind of flatten out that pizza crust and make it straight, I might measure it in inches, centimeters. If it's a kind of absurdly large pizza, it might be miles, and so on. So length is just measured in regular length units. So the length of an arc, yikes, shaky hands. The length of an arc is just a part of the circle's full distance around, also known as the circumference. If I want to know the length of my crust, well, I'm going to compare that to the distance all the way around. And so the formula for circumference, we briefly looked at that in the last topic, but then we didn't really use it. I just wanted to introduce it there. The formula for circumference equals 2 times pi times the radius. So below, just a few examples practicing with circumference, not thinking about arc length, just thinking about the full pizza all the way around. The circumference of a circle with radius of 5 feet, we're going to answer this in two ways. We're going to give the exact answer, or you might say in terms of pi. We're also going to give an approximation rounded to 2 decimal places. We'll talk about what that means in just a minute. Circumference of a circle with a radius of 5 feet. Circumference equals 2 pi times the radius. And in this case, that's 2 pi times a radius of 5. So if you have those blue and white calculators, it's going to give you the exact answer pretty much any time it possibly can. And then your toggle button is going to take care of the rest. If you don't have a blue and white calculator, I'll take care of it in just a minute. But the most important thing that I could tell you about using a calculator here is I know that you know that pi is approximately 3.14. But your calculator knows more than that. Your calculator knows that it's 3.14159, blah, 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 blah. So your calculator has a pi button on it. Take a minute, locate the pi button. On the blue and white calculators, it's pretty easy to find. On the larger, those graphing calculators, you're going to hit second, and then you're going to hit the little house top on the right, and a pi symbol should show up on your screen. So type in 2 pi symbol times 5, and it's going to give you one of two things. If it gives you a decimal, we'll deal with that in just a minute, but on the blue and white calculators, it's going to give you the exact answer, which is 10 times pi. If it gave you 10 and then the pi symbol, cool, that's the exact answer. If it gave you a decimal, then it should have given you 31.415, so that rounds up to a 2. And again, the blue and white calculators, the little toggle button takes care of it. But what if, Miss Kennedy, it didn't give me that nice 10 pi at all? No worries, anonymous child, we got you. If you have the bigger calculators, then the pi button is actually not great for you. Instead, what you're going to do is just do everything else. Just do 2 times 5, hopefully in your head, and you'll get 10. And then just say, oh, right, and there was a pi sticking around, so there's a pi here. So again, the blue and white calculators are going to give you the exact form first, and then toggle will give you the approximation. Other calculators, you might have to do the stuff without pi, like the 2 times 5 to get 10, and then just put a pi on afterwards. For the next couple of problems, make sure you're reading them carefully. Circumference of a circle with a given diameter. And then over here, I didn't even tell you what the radius was. So if you want to pause me and see what you can do with those on your own, please feel free, but I'm going to keep on going with these. So to find the circumference given diameter, what I recommended earlier was circumference equals 2 pi times the radius. We'll see in just a minute, I could do this a little bit faster than what we're about to do, but this isn't going to take too long. They told me the diameter was 8 centimeters. So if the diameter is 8 centimeters, just do times, the diameter is 8, so the radius has to be 4. And then depending on your calculator, depending on how you approach it, what I'm going to do is just the nice easy parts. 2 times 4 is 8. And oh yeah, there was a pi sticking around. And then 8 pi on my calculator is 25.13. Here for the units, length here would be measured in centimeters, just like the diameter was. So this works, it barely took any effort. What some people would do instead, of course it's totally fine, instead of c equals 2 pi times the radius, some people instead just say circumference is pi times the diameter. There are good reasons to think of it that way as well. I just personally prefer the first. It connects a little bit better to some other stuff that we do, but who cares? In this case, the diameter was 8, so I could go ahead and do that here. If you look in blue, basically we divided by 2 to get the 4, but then we multiplied by 2 in that version of the formula. Doesn't matter how you get there, as long as you get there. And then here, the circumference was given to me. So I'm going to start, and this is going to be my big tip for this whole thing. I'm going to start just by writing the formula down, letters, variables, and all. Then I'm going to carefully plug stuff in. So the circumference is 43 inches. So this time The number they gave me is going in for circumference rather than radius, equals 2 pi r. This is another calculator moment. If you type this into your calculator, there is one really common wrong answer, and I can tell you why it's going wrong. Try typing that, or sorry, we haven't actually solved it yet. If I divide both sides by 2 pi, right, to get the r by itself. If you get an answer of 67.54, no offense, but it's wrong. Because what you think you're asking your calculator to do is not quite what you're asking it to do. One way of dealing with this, I'll talk about why that goes wrong in your calculator, but one way of dealing with it is just to think of the 2 and the pi as separate steps. So first, I'm just going to get rid of the 2. So 43 divided by 2 is 43 over 2, or 21.5. And then the right-hand side still has a pi, and it still has an r. So then as a separate step, I'll go in and divide by pi. This time I didn't ask for the exact answer because it's just a little nastier to get it. But to 2 decimal places, 6.84 inches for the radius. So doing this as 2 steps, getting rid of this whole number first and then getting rid of the pi separately, is one way of avoiding this mistake. Another option, which you might prefer, 43 equals 2 pi r. I'm allowed to get rid of both of those at the same time. I can divide both sides by 2 pi, and all is well, as long as I remind my calculator to group the 2 and the pi together, either with parentheses to divide by everything, or by using the actual fraction button. On those blue and white calculators, using the fraction button is a way of telling the calculator you want to divide by the 2 and the pi together. The way that your calculator is interpreting the question to give you that wrong answer of 67.54, if you type in 43 divided by 2 pi, what your calculator thinks you're asking, and really what you are asking, is it's asking you to do, or you're asking it, to do 43 divided by 2 times pi. But if we think of order of operations, your calculator is going to do 43 divided by 2, then it's going to multiply that by pi. And that's how we get this really common wrong answer. So we talked about a few ways to deal with that. One option is just to do it as 2 steps. That's probably what I would recommend. Another option is to use parentheses to group it together. And then a third option is a fraction button. Regardless, this question wasn't a terribly difficult one, but there are some calculator tricks there. 6.84 inches. Okay. So let's actually start talking about slices of this pizza and the crust that they get. So the instructions here say divide the circle into 8 congruent sectors, shade 3 adjacent sectors. So sector really just means a slice with the corner at the center. So I'm going to see how this works for me. There we go. So I'm going to split it. Whoops. Thought I had it, you guys. So I'm going to split it in half. And then split that in half, and then split those in half. Oh, this is going terribly. Yikes. And then split that in half as well. Look at how beautiful that is. I've done a fantastic job, right? False. Shade 3 adjacent or touching sectors. So I'm going to shade this one, and that one. Okay. What we're going to do here is just kind of walk through why this formula works the way that it does. So they told me the radius of this circle is 20 centimeters. So the circle's full circumference equals 2 pi r. So I have 2 times pi times a radius of 20. I'll just deal with the nice numbers first. 2 times 20 is 40. And then there was a pi hanging out. I could turn that into a decimal, but that's not really the point here. The fraction that is shaded, well, this goes back to like elementary school. I split it up into 8 congruent sectors or slices. I shaded 3 of them, so I hope we know that we have shaded 3/8 of the circle. But then a newer thing, the central angle of the shaded part. We'll think for a second about how we would figure that out. The entire angle around here, right, would be 360 degrees if I had the whole circle. But I have 3/8 of 360 degrees. So that's 3/8 times 360. And I should do that in my head, but I didn't. Don't tell your parents. 135 degrees. This angle over here is 3/8 of the full 360, so it's 135 degrees. Or you could even say, because of the right angles we made as we were doing this, each slice got 45 degrees. 45 times 3 is 135. But then the new thing here is dealing with the arc length, right? But just as we did for the central angle, I had 3/8 of the full angle. So now I want 3/8 of the full circumference. So 3/8 of our full circumference, 40 pi. So that's 3/8 times the full circumference. And so I end up with 15 times pi in exact form, or about 47.12 centimeters. If I go with an approximation, it doesn't matter here. 15 is looking a little rough. Let's try that again. Okay. You're not going to have to do that process every single time, but the idea here is we shaded 3/8 of the circle. So we got 3/8 of the angle, and we got 3/8 of the crust as well. So that idea helps us deal with arc length. And there are a couple ways, kind of a couple different formulas here. There are different ways of thinking about it. For me personally, I don't really use a formula at all. So if you have other options, as always, no worries. But there are a couple different ways of looking at this. One of those is kind of a nastier looking formula, but some people like it better. We figured out by this point what I like is probably not the same as what everybody else likes. So for arc length, I'm just going to call that capital L instead of writing out arc length every single time. But what we're going to do, since arc length is part of the full circumference, I'm going to start with the full circumference. But we didn't get the full circumference, we only got a fraction of it. In our example, it was 3/8. So I'm going to make a fraction out of 360. And up top, I'm going to put a weird little symbol that we've seen, like, I think once before, maybe not even that. This guy. It's a Greek letter. It's called theta. And it just means something that is measured in degrees, whether that's a central angle measured in degrees or an arc measure that we measure in degrees. So my formula here, length equals 2 pi times the radius times something measured in degrees divided by 360. Another option is to think of how we had 3/8 of the angle and also 3/8 of the full circumference. And so I'm just going to set two fractions equal to each other, and then we can cross multiply. This one maybe works a little bit slower sometimes, but sometimes it works really fast. Like, who knows, right? It's totally up to you. Take your pick, as always. But what I'm going to do is the fraction on the left, I'm going to think of it as my arc length, which is the part of the crust I got, out of the full circumference, which would be the distance around the whole circle. So basically what we're starting with here is that the top is the part that we're looking at, and the bottom is going to be the whole thing. And then on the right-hand side, I'm going to think about angles. So theta, again, just something measured in degrees, either an angle measured in degrees or the measure of an arc in degrees. That's the part that I have out of 360 because that's the total degrees for the entire circle. That looks like what we did with similar triangles, right? We set up proportions and then we cross multiplied, and that was one way of approaching those problems as well. And if you liked that, then you can do that here. Totally up to you, just whatever makes more sense. Okay. So then just some examples down here. I'm going to do one with the first version of the formula. I'll do the second with the other version, and then the third I'll let you pick. So find the bold arc's length. As I said earlier, probably the best advice I can give here is to start just by copying the formula with all the letters in it or all the variables in it, and then start plugging stuff in. Okay, so let's see what we have. They gave me 5 centimeters. So I look at what I have in my equation or in my formula. 5 centimeters is the radius. They also gave me the 76 degrees, and it's as simple as noticing those degrees up there that tell me that that's theta rather than anything else. If it's in degrees, it's got to be theta. So 2 times pi times 5 times 76, or 76 degrees, divided by 360. In this case, that first version of the formula was definitely the easier choice because L is already by itself. All I have to do is type it into my calculator. If you have the blue and white calculator, just go for it. If you don't, you can type in everything except the pi. 2 times 5 times 76 divided by 360. You might have to hit math, enter, enter, if you have one of the big calculators. Again, that was math, enter, and then enter again, if you have one of the graphing calculators. And that gave me 19 over 9. And then all you have to do is throw the pi in to your answer, and you're good. If you had a blue and white calculator, you can go ahead and just hit the pi button, and it might put the pi in the numerator, and that's totally fine as well. And since we're dealing with length, in this case we're measuring length in centimeters, so our units would be centimeters. Okay. For the second one, I'm going to try the other version of the formula. So again, I'm just going to copy exactly what it is. Arc length over the full circumference equals my degrees out of 360 degrees. And then we look carefully and we see what we have. So 6 inches, that's the radius of the circle. Here, I'm still given something about this arc, but it's not in degrees. This is in inches. If it's in degrees, that's when it can go in for theta. This is not in degrees. Don't put it in for theta. This is a length. It's measured in inches. So we just plug some stuff in. 13 over 2 pi times 6 equals theta over 360. And if you prefer, just to say like, oh, I only have one thing left, we could call that x instead of theta. It doesn't matter. And then we can cross multiply. So 13 times 360 is 4,680. And then going the other direction, I have 2 times pi times 6, so that's 12 pi, times the x up here. And then this is just where we have to be cautious with the calculator. So if you divide by 12 pi, make sure that you either use the fraction button if you've got one, or that you group it together with parentheses. Or, just to be extra safe, you can divide by 12 to start with. That gives me 390. and then deal with the pi. So now I'll divide by pi as its own separate step. 390 divided by pi, 124.14. And since they were looking for the measure of the arc, it's going to be in degrees. Measure, this theta that we were looking for, what we ended up calling x, that is definitely going to be in degrees. So what I'd like you guys to do, pause the video and then try this one on your own. And if you get stuck or if you're just ready to check your answer, then unpause and come on back. If you're going with the first version of the formula, once you get to this point, which you will in a lot of these problems, we've seen stuff like this before. I see division by 360. So I'm going to multiply both sides by 360 just to cancel it out over here. And then again, I should be doing this in my head, but I'm very tired. This has been a long week. 5,400 equals 80 pi r, and then you can solve it from there. If you're using the other version, I'm going to pause for just a second and I'll be back with the other version. If you went with the other version of the formula, you're still plugging in 15 for the arc length because that was measured in yards. You're still plugging in 40 for theta because it was measured in degrees. And then for this version of the formula, you cross multiply. So you can see that with my red arrows. And you'll notice I end up in exactly the same place as the other version did. My job now is to get rid of the 80 and the pi, either as one step by using parentheses, or as two separate steps, dividing by 80 and then dividing by pi. But 21.49, and we're looking for a radius, so in this case, that would be measured in yards. So that does it for this topic. There's a second topic for this week. There's a quick check for you with, I think, 3 questions related to what you just did. And also in OneNote, you, of course, will find the homework. And for this one, all of them are good questions and all of them have answers online, but only the even numbered problems are required. So I will see you when you are ready for topic B.2, which is sector area. And that's our second thing for this week. So I will quote unquote see you guys soon. Bye.